Hello and welcome back to California Geology. Today I'm going to talk about the Pleistocene glaciation that occurred in the Sierra Nevada. And when we look at it, this Pleistocene epoch occurred from 2.6 million years ago to 11,700 years ago. And during this time, this Pleistocene time was known as the Great Ice Ages, but it wasn't that it was always frozen during that time. In fact, there were periods probably during this Ice Age time where glaciers retreated and it might have been a little bit warmer than it is today. But certainly there were several advances and retreats. In fact, in the continental region, the continental glacier that was over North America, there's four well-documented glaciations, and really there's more like 20 overall. But if we look at them, there's this one more recent one, which is the one that was about 20,000 years ago, called the Wisconsin. And then before that, there's this Illinoisan, there's a Nebraskan, which is really known as a pre-Illinoisan, and there's several advances and retreats A through letter K. So quite a bit of detail can be worked out from the glacial deposits found in Iowa, Kansas, Illinois, in Canada to work out these ages. But the key thing is that the Pleistocene epoch wasn't entirely glacial ice. There was periods where there was a glaciers melted back, they advanced, melted back, advanced. And in the Sierra Nevada, where the glaciers are smaller, so they were more susceptible to climate fluctuations because they were smaller. There's at least 17 different tills that represent glaciations that are recognized in the eastern Sierra Nevada. They get kind of complicated. There's quite a bit of debate as to their ages. Hardin talks about it on page 208 there about the debate on the ages, because some of the methods use basically how the moraine, the till weathers on the moraine crest. If a moraine crest seems to have more exposed boulders, it's probably younger, whereas a moraine crest with boulders being buried is probably older. So there's some relative techniques. Not all of them work well. Another method is you could go around walking on a crest of moraine with your hammer and hitting the boulders. If the boulders sound hard, giving you a whack sound, then it's probably pretty young. It hasn't been exposed to weathering very much. Whereas if you walk in a moraine and you hit the boulder with your hammer and it goes more like a thud, that means it's more weathered. It's an older moraine. Again, pretty sketchy relative dating techniques. Depends on the rock type for the weathering rates and the climate for weathering. Other methods employ looking at cosmogenic chlorine, how chlorine can accumulate on surface boulders, and they use isotopic methods, and it's quite complex, and they get some ages that seem to correspond to some of the ages I'll point out here. But again, that just brings more debate into the timing of these glaciations. But at least based on mapping, based on field evidence, where you can go out to the eastern Sierra Nevada, look at the glacial moraines and say, well, yes, I clearly see these 3 or 4 glacial stages. We can simplify the story, and that's what Glasner and Stock have done here in the article I want you to read by them. And also Hardin talks a little bit about these stages as well. So if we look at the simplified story here, the oldest glaciation seems to be, at least that we have pretty good record for. I'm sure there were some even older than this. Seems to be this McGee till. And the McGee till seems to be about 1.5 million years old based on some lava flows that we can date that either occur below or above that till. One thing about this McGee, in fact, it should be called the till, is that it doesn't really form any moraine crest, because they're so old, the moraine crests have been weathered and worn away. Same thing with the Sherwin till. This one, again, doesn't seem to have any moraine crest left, but we do see extensive evidence of this glacial debris being deposited. And we have a pretty good age on this, because this glacial till is overlain by the Bishop Tuff. Remember, the Bishop Tuff erupted roughly 760,000 years ago. So that means that the glacial epoch of this Sherwin Hill must have occurred before 760. And the most recent age is really like 820,000 years ago, based on some of those cosmogenic chlorine-36 isotope ratios. But we'll call it 800,000 years. So there's pretty good evidence for that one. And then as we get younger, obviously the ages, we see better evidence, better moraine crests and better deposits. So there's a Tahoe glaciation. Best example is in the Tahoe, Lake Tahoe region, where we're seeing glacial moraines dating to about maybe 140,000 to 80,000 years ago. Again, there's some controversy here as to whether this is an earlier Tahoe and a younger Tahoe. In fact, there's even evidence of another glaciation in here called a Mono Basin glaciation, but maybe it's all part of the Tahoe. It might be Tahoe advanced, then retreated a little bit, then advanced again. So people are kind of lumping this together, which is probably a good thing. Instead of breaking it out, kind of lump it together and call it a packet of glaciation during this time. But the one we have really good evidence for is obviously the most recent extensive one, the Tioga glaciation, which corresponds to that Wisconsin glaciation that for continental settings. And this occurred between 26,000 and 18,000 years ago, the height of which was probably about 18 to 20,000 years ago. And so this is the one that's left the best evidence of glacial striations and moraines in the Sierra Nevada, the fresher, more cresty or rigid moraines in the Sierra Nevada. And then there is this little ice age called the Matthes. Matthes was a French geologist studying some glacial features in alpine terrains. And this little ice age seems to have occurred between about 1500 to about 1850. Your Hardin says about 1300, but it seems to be more in the range from 1500 to 1850. This number is kind of unusual. That glaciation seems to end when something started. And right around 1850 is when the Industrial Revolution started. We started burning fossil fuels, right? So maybe the burning of these fossil fuels, adding more CO2 to our atmosphere, marked the end of this little ice age. But that's one of the evidences we have there for glaciation. Now, the two that I want to focus on are, again, the Tioga and the Tahoe glaciations. So remember, Tioga, the most recent glacial advances. Tahoe, these are the most conspicuous because they form really large moraines. It was an extensive glaciation, quite a bit of erosion, probably because it involved a longer period of time, and so there was more plucking, abrasion, bringing down boulders from the Sierra Nevada. In fact, in the Glasner and Stock textbook, they say that glaciers erode anywhere from 3 to 35 feet per 1,000 years. So every 1,000 years, they're eroding anywhere from 3 to 35 feet into the bedrock, carving out the valleys, making those wide Yosemite-like valleys, right? Those U-shaped valleys. So longer period, more debris, larger moraine. So there is considerable controversy regarding the exact age of the Tahoe, and many geologists argue that there should be a younger and an older Tahoe. And on the slide, on the PowerPoint, I'll show you the evidence for that. But anyhow, those are two. Just note that this Tahoe is the most conspicuous along the eastern Sierra Nevada. One question you may have is why, the glaciers probably occurred, and they did. They occurred not only on the east side, but also on the west side of the Sierra Nevada. For example, here we're looking at California kind of going east on its side here. So north is over here, south is over here. So we're looking at the Sierra Nevada. There's Lake Tahoe, Mono Lake. All the rivers coming down to the Central Valley. Here's Sacramento down over here. This is actually from your book, Figure 841. During this time, the Sierra Nevada had alpine glaciers extending for about maybe 200 miles. It was anywhere from 20 to 30 miles wide. Some of the glacial valleys were as thick as 2,000 to 3,000 feet deep in ice. The northern extent is up here by the Yuba River, whereas the southern extent was Mount Whitney. Mount Whitney was glaciated, but note that Olancha Peak over here by Owens Lake, that's the place where Crystal Geyser gets their water. Note that there was no glacier there, right? The glaciers were up north of there from Mount Whitney up to about the Yuba River region in the northern Sierra Nevada. Now, I was mentioning, why do we talk mostly about the eastern Sierra Nevada moraines? And there were a bunch of moraines over here on the west side, but since the west side has more stronger, bigger rivers, well, those moraines have pretty much been washed away. But since the east side is a rain shadow, we talked about the rain shadow and the orographic effect, then these moraines have been somewhat preserved. We can see these great lobes of moraines going out into the Owens and Mono Basin. In fact, one of the important one I want to point out here is the Big Pine moraine. I'll show you a picture of Big Pine, and this, you can see this glacier really went out into the valley, and we see big moraines out there that document that glacier moving out into the Owens Valley there. Now, again, we're seeing these spectacular moraines between Bridgeport and Bishop. Again, it's an arid climate out there. And then we want to emphasize that moraines are very different in character on the east and west side, again, because they've been eroded, right? So those on the east side are large and impressive and stand several hundred to 1,000 feet high, so very high moraines. They projected out as much as 5 kilometers from the mountain front, right? So that's like these Big Pine moraines here. So that's over 3 miles from the mountain front there. The moraines on the west side over here of the Sierra were probably just as impressive as those on the east side when they formed. However, the moraines on the west side were confined to deep valleys like Yosemite and were washed away by major rivers that drained to the west, right? So the Mono rivers probably washed away those moraines. And then there's a couple of, in fact, there's a video I want you to watch on with Greg Stock in it, one of my former TAs, who's now the park geologist of Yosemite National Park, and one of the co-authors of this book on the geology of Yosemite. But he actually goes up to the McClure and Lyell glaciers in this video, and you'll see that he goes to the Bergschrund, and then he goes and looks at the gravel and boulders that are abrading the bedrock under the McClure Glacier there. So there's still some glaciers in the Sierra Nevada. They're small. Unfortunately, they seem to be melting back quite rapidly, but that's just, because of the global warming we're experiencing. But anyhow, let's stop here, and then we'll continue on.